Lesson 3, Composite Functions. Composite functions are formed from two functions. The output of the first function's result is used as the second function's input. So for example, if we have f of x and g of x, we're writing f of g of x. Means that what we're going to do is substitute in g of x for x in f of x. So we end up with 3 times g of x. G of x is x squared, so we have 3 times x squared, or 3x squared. If it's written as g of f of x, this time what we're going to do is substitute in f of x for x in g of x. So x in g of x is x squared, so the x becomes f of x. F of x is 3x, and so we end up with 3x all squared, or 9x squared. So in this one, order is very important when we're evaluating. The composition of f of x and g of x is defined as f of g of x and is formed when the equation of g of x is substituted into the equation of f of x. So f of g of x, another way to write it is to write it with this open circle. Be careful that f of g of x is not the same thing as f times g of x. Right? Two different things. This one is multiplication. This one is a composition. Okay, evaluate a composite function. If f of x equals 4x, g of x equals x plus 6, and h of x equals x squared, determine each value. Now in this case where we're asked to determine each value, we can do it a couple of different ways. I think that the easiest way is to actually evaluate g at 3 first. So if we do that, we're going to substitute in 3 for x in g of x. We end up with 3 plus 6, which is 9. We're then going to take this answer of what our function g is equal to and substitute it into function f. Now that we have our answer for g at 3, we're going to substitute that value of 9 into f of x. So we're going to replace x with 9. So in f of x, then we have 4 times 9, or 36. So f of g at 3 is 36. The other method would be to substitute in the equation for g of x into f of x for x, come up with a new equation for f of g of x, and then substitute in 3. Part B is g of h of negative 2. So again, I'm going to find h of negative 2 first. So I end up with negative 2 squared, or 4. I'm now going to take that value and substitute it into g of x. So I'm going to have g at negative 4 is equal to negative 4, sorry, that should be positive 4, plus 6, which is 10. Part C. Part C is h of 2, so I need to start by finding out the value of our function h at an x value of 2. So we end up with 2 squared, which is 4. I then need to substitute that in to h again, and we end up with 4 squared, or 16. Compose functions with restrictions. Consider f of x equal to root x minus 1 and g of x equal to x squared. Determine f of g of x and g of f of x. State the domain and range. Okay, so part A. Let's figure out what f of g of x is. So to do this, we want to substitute the equation g of x in for x and f of x. And so we end up with the square root, and instead of x, we end up with x squared minus 1. Simplifying, we don't need those brackets, and so we just end up with the square root of x squared minus 1. The other part of part A is to do it the other way around, and so we're going to do g of f of x. So in this one, we want to take our f of x and substitute it in to g of x. So g of x is x squared, but that x is now the square root of x minus 1. When we square a square root, we just end up with what's underneath it, and so g of f of x is just x minus 1. Part B is to state the domain of f of x, g of x, and then our two new functions. So for f of x is a radical equation, means that what's underneath that root sign has to be 0 or bigger, can't be a negative number. So that means that we're looking at the domain, that x minus 1 has to be greater than or equal to 0. So therefore, x has to be greater than or equal to 1 as the domain. We can write that as 1 to infinity, and 1 is included in that. For g of x is the equation x squared, and so x can be any real number, or negative infinity to positive infinity. Now, for our first composite function, f of g of x. What's underneath that root sign, again, has to be a positive value. So for the function f of g of x, we know that what's underneath that root sign, x squared minus 1, has to be greater than or equal to 0. And the only way it's not greater than or equal to 0 is if we substitute values in for x squared in between negative 1 and positive 1. Anything in there, when we subtract 1, we will end up with a negative value. So this means that x has to be less than or equal to negative 1, right? We want something outside here or this way. And x has to be greater than or equal to positive 1. So there are our restrictions on our domain. We can write it as negative infinity to negative 1, or 1 to positive infinity. Our last function is g of f of x. Just a reminder that that equation ended up being x minus 1. But we need to look at the restrictions. The fact is that we substituted f of x into g of x. So any restrictions on f of x, we can't substitute any values that are not allowed in f of x into g of x. So because f of x had a domain of x being greater than or equal to 1, this is also our domain for g of f of x. So just to clarify, f of x, we cannot substitute in values into f of x such as negative 2. If I substitute in negative 2 in there, I ended up with an undefined value. That means I can't substitute in all of those restrictions then apply when I do f of g of x. Determine the composition of two functions. Let f of x equal x plus 1, g of x equals x squared, determine the equation of each composite function. So if we're determining the equation of f of g of x, means we're going to substitute in g of x. So substituting x squared in for x. And so we end up with y equals x squared plus 1. Y equals x squared plus 1 is a parabola with the vertex at 0 and 1 and normal opening, and so the graph will look something like this. The domain of this function is all real numbers. The range of this function is that y has to be greater than or equal to 1. Y equals g of x means that we're going to substitute in, y equals g of f of x means that we're going to substitute in x plus 1 into the function g. And so we end up with y equals, and instead of x squared, we end up with x plus 1 squared, which again is a parabola. This time it's been shifted to the left 1 unit, and so our graph will look something like this. The domain this time, again, is all real numbers. The range is that y has to be greater than or equal to 0. If y is f of x, means we're going to substitute in x plus 1 into our equation for x. And so we end up with y being equal to x plus 1 or y equals x plus 2. Y equals x plus 2 is going to be a straight line. We'll graph that one in a minute. Let's figure out the equation for part D as well. G of x means we're going to put in x squared into g. And so we end up with y equals x squared, all squared, or y equals x to the power of 4. Let's have a look at those two graphs. So the first one was the graph of y equals x plus 2. Y equals x plus 2 has a y-intercept of positive 2, a slope of 1, and so it will be a straight line like this. The domain, x can be any real number. The range, y can be any real number. Our last graph was the equation y equals x to the power of 4. So x to the power of 4 is a polynomial function that will look like y equals x squared. So it's going to start in quadrant 2, end in quadrant 1. It has an x-intercept at 0, 0, and it's going to flatten out as it gets there. The only x-intercept that it has is, the only x-intercept that it has is at 0. So it's going to come close, it's going to flatten out, and then it's going to continue up in that direction. The domain is all real numbers. The range is that y has to be greater than or equal to 0. Determine the original functions from a composition. So this time we have a combined function and we need to try and simplify it. So for part A, we have h of x equals x minus 2 squared plus x minus 2 plus 1. And so sometimes we want to look for a function within a function. If we're trying to find f of x and g of x is what's been substituted in. And so in this case, g of x is going to be that x minus 2. We could rewrite that then to show that f of g of x would be g of x squared, right? I'm replacing the x minus 2 with g of x, plus g of x plus 1. So f of x is then x squared plus x plus 1. So you can see that pattern that's arose. For part B, we have h of x being equal to the square root of x cubed plus 1, we're going to let our initial function g of x be what's underneath that root sign. If g of x is x cubed plus 1, then f of x would have to be root x. And we can check that by substituting in. If we replace x with x cubed plus 1, we end up with our h of x. Our last question is an application. It says a spherical weather balloon is being inflated. The balloon's radius, r in feet, after t minutes, is given by r equals root t. Express the volume of the balloon as a function of time. Okay, so part A. Usually we express volume as a function of the radius. As a function of the radius, we're talking about a spherical balloon, so the equation for the volume of a sphere is 4/3 pi r cubed. Writing it in function notation, this says that the volume is a function of the radius. If we now want to write it so that the volume is a function of time, what we need to do is replace that r cubed with something involving time. And we know that our radius as a function of time is root t. And so we're going to substitute in root t into that equation. We can do a little simplifying there. And we end up with the volume as a function of time is equal to 4/3 pi times t. And if I write that in exponential form, it's 3/2. Part B says after how many minutes will the volume be 4,000 cubic feet? So in this case, we know the output, or we know what V of t is equal to. 4/3 pi, and we're looking for t this time. This is just an equation that we now need to solve. So we are going to multiply both sides by 3/4 to get rid of the fraction. When we do that, we end up with 3 times 4,000 all over 4 equals pi t to the power of 3/2. I can divide both sides by pi. So that makes it 4 pi on the bottom on the left, and on the right I'm left with t to the power of 3/2. 4 goes into 4,000, leaving me 1,000. And so I have 3,000 over pi equals t to the power of 3/2. If that exponent was 1/2, I would multiply by 2, or sorry, I would square it to get t by itself. So this time, I'm going to, both sides, I need to multiply by the raise it to the reciprocal power. So I'm going to raise both sides to the power of 2/3. On the right-hand side, I would multiply those exponents, and it would leave me with 1. On the left-hand side, I then need to evaluate that on my calculator. Substituting in and plugging into your calculator, you should end up with an approximate answer of 96.97. And so it's approximately 97 minutes to reach that size.